This is Interactive Computer Graphics Week 3. The topic we discuss here is 3D geometric modeling. So the challenge behind this is that the user interface is still mostly two-dimensional. So the question is how to complement missing information, so mainly depth here. So user input 2D and how to get 3D from 2D. So that's a problem we address here. And solution in general is that user interface and automatic inference leveraging domain-specific knowledge. So if you do not know what you do, it's almost impossible to infer depth. But if you know what user want to do, if you limit the domain, and you can get reasonable results. So that's the basic idea behind the works I will introduce here. And here are the topics we discuss in this week. The first one is suggestive user interface for modeling of architectural models, and then sketch-based modeling of low-tuned stuffed things. And then we discuss a shape control by curves, and then flower modeling, and then volumetric texture synthesis. The first one is suggestive interface. So the work was published as a Chateau, a suggestive interface for 3D modeling. And the motivation is here. So current graphical user interface is dominated with many buttons, menus, and also even more nested menus. So it's very hard to find desired command, and also it occupies a huge screen real estate. So that's a problem we want to address. So our approach is instead of asking the user to explicitly specify the commands, we only ask the user to provide hints about the operation you want to do in the main screen, main field. So suppose you are working on 3D modeling, and if you want to do related to these three elements in the scene, user just highlight these three, which means a hint was a computer to infer the request. And then computer look at the hints and then proposes related operations. In this case, the system proposes a box and also other two possibilities. So in other words, the user first gives arguments for the command, and then system automatically infers the command. So let me show you a demo. So here is a three-dimensional modeling system with a 3D space inside, and then you can sketch lines in this way. But here, instead of using many commands and menus, we simply allow the user to highlight lines. And then for these highlights or hints, system presents some suggestions. For one is drawing a plane, and another is drawing a triangle, the other is drawing a rectangle. And you can also ignore them and then click more. And then given these three perpendicular lines, system predicts or suggests to make a rectangle, a box. And then again, if you draw a line here, then given these hints, system suggests to cut a box. You can also go back and then add more lines, and then given these hints, system suggests to cut a corner. So in this way, user provides a hint to the system, and then the system presents suggestions. So in this way, user does not require to specify command in the huge command list, and the user can focus on the visual content of the task. And if you highlight this, and then system suggests drawing a plane, and the user draws, for example, triangle here, and if you highlight these three, system suggests to make a face inside. And then if the highlights one more, then system suggests extrusion. And one interesting operation is like this one. If you highlight these two and also one line here, about the third, and then system exactly divide into the three. Or user can also draw line somewhere here, and then system suggests to divide it into 4. So in this way, you can generate this kind of diagram just by repeating operations. And after some operations, you can get this kind of results. And this kind of operation is very useful for repetitions and also some symmetric structures and so on. And let me briefly describe the implementation behind the system. So this is the input scene, so highlighted elements and then no highlighted elements. So taking this input scene, then system is equipped with multiple suggestion engines. So they are kind of parallel engines working independently, and then each engine consists of two parts. One is examination part and one other is generator. And the examiner examines the scene and then tests whether the scene matches with the expected rule. And then if it passes the examination, and then the generator generates a resulting scene. So this is a very hard-coded pre-programmed module provided a programmer, but they all works in a parallel, and then specific engine reacts to the specific input configuration. And here's a list of suggestion engines we implemented in these applications. One is drawing plane. Given a hint, system generates a drawing plane passing through the hint. And also if you highlight closed loop, it suggests polygon, and the perpendicular two lines suggests a rectangle, and three lines suggest a box, and system suggests extrusion and pyramidal shape. And these are advanced ones like resizing or bridges, connecting two polygons, and extrusion, and this is cutting out, and also corner cutting and trimming, and intersection, duplication, repetition, mirror image, and so on. And the philosophy or concept behind this like this. So current standard user interface is like this. The user provides very explicit command or very explicit instruction to the computer, and then computer just blindly, simply follows the instruction. However, what we propose is more friendly human-to-human-like interaction. So user is working on the visual task directly, and then computer implicitly observes the action and then provides help as suggestions. And I think this kind of working style can be very useful. One possible application is like this. So in your PowerPoint or any presentation or drawing system, you have alignment tool. But alignment tool is hidden somewhere in the menu, and it's not easy to find. For example, in this PowerPoint, you can get it from somewhere like home and somewhere, I don't know. Height, alignment, and somewhere, but it's not easy to find. However, if you highlight these four almost aligned elements, I think it's pretty reasonable and also useful for the system to suggest vertical alignment in align left or align center and suggest to the user. And if your user likes it, and they just click it and they get the result. And this can be a very powerful help for the user. So that's it, and the original paper was published in 2001. And this work, our work is strongly inspired by a previous system called the sketch system. So this sketch system takes two-dimensional gestures, and the system automatically generates this kind of three-dimensional scene. So what they do is very interesting. So your input is 2D, and you need to infer 3D position. To do it, the system uses a rule that every object have to put on top of existing 3D object. So in this way, the system efficiently computes 3D depth of two-dimensional gestures. And showing multiple candidates for the user to choose is also presented before, and represented work is called Design Galleries and published in 1997. And I also recommend you to take a look at this work. Thank you.